Hi guys, welcome to another episode of Marine Technical Training Academy. I hope you enjoy the next coming videos about that topic. We are going to start from the bottom with the study of the conversion, the calculation of the electric motor, the battery banks, and we are going to do the process complete. Okay, number one is the calculation, the sizing of the electric motor, the sizing of the electric motor. If you remember in other of my previous classes of transmission and electric classes, I explained that process. But I am going to create one specific video for that purpose, to explain how they calculate according with the actual capacity of the engine in horsepower and the output torque in foot-pounds of the original gasoline engine, how was the criteria to select the electric motor according with the horsepower, according with the RPMs, and according with the output torque. With those three factors, they select the proper electric motor. I am going to create one video exclusive for that procedure. For today, I want to tell to you that at the end of the equation, they discovered that the electric motor required to supply the same power than the original gasoline engine is around 40 kilowatts. Three-phase AC motor, synchronic motor, 40 kilowatts. However, because they don't have in that moment that motor with that capacity, they did the conversion with other motor of a 15 kilowatts three-phase motor. And the result was perfect. The performance of the car was perfect. Okay, because the topography of Cali, Valle in Colombia was good. But in a previous step, we are going to improve the motor for other motor of 40 kilowatts. That's the recommended motor. However, this process in this moment is with a motor, three-phase motor, electric motor, air-cooled of 15 kilowatts. Okay, this is number one, the motor. And the motor is ready. This is the motor. The motor is ready, three-phase motor. Okay, what is the configuration? What is the design? I am going to show the wiring diagram used for Oscar, for Julian, and the team, the students, because the students participate all the time in this procedure. Those are the students. It's a great group of students with a lot of passion, with a lot of dedication. They work during the night, during the morning, during the evening, more than full time, dedicated to the project. They create a wonderful PowerPoint presentation about the process. And one of the parts of that presentation is the wiring diagram. This is the wiring diagram. As you can see in this diagram, in the left side is the motor, the electric motor, three-phase motor. I am going to explain the configuration. What will be the configuration of this fully electric car? It's a Kia Soul. Okay, this is the motor that they calculate should be 40 kilowatts, but in this particular project, they want to use a 15 kilowatts three-phase motor, synchronic motor. I remember it's 8 degrees the phase angle. Okay, that's the motor, three-phase. That motor will receive the electricity, three-phase AC current from the inverter, the second box. Those three terminals are the outputs of the inverter. Of course, the inverter in the input receives DC current. The current coming from the battery bank, the orange. The current is coming from the battery bank, 96 volts DC with in between 200 and 300 amps entering in the inverter, and the inverter converts the DC current into AC current, 3 phases entering in the motor. That's the process. Okay, number 1. Remember that I mentioned that if you remove the engine, you need supply power for other accessories that you have in the dashboard, that you have in the original car. For that reason, they included one DC to DC converter, that rectangle. That DC to DC converter reduced the 96 volts into 12 volts or 37 volts, depending what part of the harness need power. In other words, with that DC to DC converter, they supply power, 12 volts, for the original harness of the car. And now you have in the display the original gauge, the original radio, music, power windows, all the accessories receive power from this DC to DC converter. Okay, additionally in the diagram, they have a battery charger. The battery charger, of course, will be used to connect the input power, DC power. We did that connection with the students. We connect the short power cable here, and after that in the outlet in the wall, 120 volts. That outlet works with dual power, single phase or double phase. That's wonderful. Okay, returning to the diagram, this is the battery charger. The battery charger receives the power from the pedestal, from the short power, and power the battery charger. And of course, the battery charger keep the battery bank in the bank fully charged. This battery bank, the autonomy, the capacity of the battery bank is in between 120 kilometers and 140. What is the meaning of that? You can use your car in between 140, 120 kilometers before the level of charge in the battery bank reach 60% of the total load. When the level of charge decrease 40%, is considered that the battery bank is empty. They don't want to discharge the battery bank completely. It's not recommended. Some people say, okay, but if the battery bank is in lithium, in this particular case, the battery bank is in lithium ion, great group of batteries. Later we are going to talk about the battery bank. However, to be conservative, they don't want to discharge the battery bank more than 60%, maximum 50%. It's basically to protect the car, to protect the battery bank, because the batteries are too expensive. Okay, guys, this is the situation. This is the wiring diagram. This is the fundamental of this construction.